All right, and away we go. So welcome everybody to today's session. My name is Josh Berltheim. I am the training manager at Sumo Logic. And what we're going to be doing for you today is going over, well, hopefully you're in the right class, AWS Observability, specifically using tracing and root cause explorer within Sumo Logic. And so what we'll do is, well, let's go through the agenda. Let's talk exactly about what we're going to do today. We're going to be together for the next hour, and we're going to make this somewhat interactive. The first half of today is kind of heavy on the slides, but the second half is not. We'll be doing some labs. It will be interactive. You'll be doing stuff on your keyboard. It will be more fun. So the agenda, the introduction, we're doing it right now. So we're already on our way. Next, we're going to talk about end-to-end observability, really to just kind of level set terminology. You may think of observability in one framework. We want to make sure we're talking about it together. So we'll just really go over, like I said, some definitions there. Then we'll start to talk about Sumo Logic and AWS together and how they/we can help with the observability problem and what that problem is. I'm sure you're aware of the problems that you face with observability, but we want to, of course, show those and then, of course, the solutions that we have to offer for them. And then when we talk about the solutions, we'll talk about two tools that are very helpful. The first one is Root Cause Explorer, and then the second one is tracing. And we'll do labs with both of those tools. Then we'll talk about next steps, and we'll get out of here. So that's the content for the hour. Like I said, chat for any questions, but I'm going to just get going here. So this first slide here, what we wanted to show is who Sumo Logic is. Hopefully you're aware of us. I hope so, but maybe you're not and just want to give a little introduction to who we are. And specifically today, we're going to be talking about Sumo Logic's continuous intelligence platform. As you know, digital transformation requires continuous intelligence, and businesses are leveraging a new category of software, the CI, continuous intelligence. Real-time analytics and insights from a single cloud-native platform across multiple use cases can help speed decision-making and drive world-class customer service. And so what we wanted to show is how using our analytics across your operations, your security, your business and global intelligence data can provide continuous awareness to impact your results. Now, we're not going to be talking about all four of these today, but I did want to just remind you that Sumo can assist with those. So for example, operational intelligence. Do you want to know, are your systems up and running? What is your MTT or MTTR, those mean time to identify, resolve those really critical metrics or key indicators that are driving our businesses more and more every day. Security intelligence, using Sumo to start to understand maybe who is using root access in a system. Is a person logging in from multiple locations simultaneously, and has your SIM picked it up as an actionable item? Business intelligence, Sumo can assist with viewing what pages people are frequently viewing on a website. What are they ordering? If we ran a marketing campaign, was it successful? Things like that. And then global intelligence is really how am I or how are you doing compared to other companies and observing your data worldwide. Using your data-driven intelligence to extract real-time insights and business value from massive volumes of machine data generated in the form of logs, metrics, events, metadata, traces, and other telemetry. Essentially, you have all these different sources of data, and you can bring them into Sumo Logic, and we can assist you with them. And that data is going to come from apps and microservices and cloud systems and SaaS and third-party systems, all different places you have data coming from. We have built-in apps. We won't really talk about the apps today, but I do want to just kind of remind you that they exist. What they are is a great way to get immediate functionality from Sumo Logic and from your data. Very simply, they are, somebody at Sumo has created queries and dashboards that will be useful against a variety of different sets of data out there. And you can simply download these apps, plug them in, and you start to view the benefit of your data. Right away. Like I said, we don't focus on apps today, but I still want to plug them because they are, well, Sumo, there's a lot of good things, but the apps are really a strong portion. Let's see what else is going on in this slide without drilling down on it too much. The stack, excuse me, is also supported. SaaS is supported, and Sumo can integrate with third-party apps like using webhooks and integrate with Slack, Twitter, Discord, ServiceNow, etc. Our analytics, so talking about that briefly, feature multi-tenancy where information is very secure. We have advanced analytics, machine learning in our application. We're in the cloud so that we have the ability to become elastic and adjust on the fly and be able to scale to environments based on demand. Supporting of APIs is a big deal, of course. And then on the right-hand side of the screen, what I'm trying to show here are just a variety of the different security certifications and attestations that we have. That while you personally might not care about, somebody in your organization probably does and wants to know that we are PCI, SOC 2, HIPAA compliant. FedRAMP is a big one that we accomplished. I guess it was last year, maybe earlier this year, but that's a big milestone. And then finally, who can benefit from Sumo Logic and from all this information? Well, your people and really everybody in the organization. So regardless if they're in DevOps or engineering or IT ops or et cetera, et cetera, et cetera, they can all benefit from Sumo. And so just like I said, just want to give a little, not really a plug, really more of a understanding of what we do. Hopefully you're familiar with us and you're using our product already, but if not, either way is fine. Welcome to today's session. So that's Sumo. Now I want to talk about end-to-end observability with Sumo Logic. So what I'm trying to show here with these graphics, doing my best job on this one, is to describe and discuss the difference and the definitions of observability and monitoring, just so we're all on the same page. Now, a lot of people equate observability to monitoring, and there's obviously, not obviously, but there is, of course, a carryover. There's very, very similar, but there is a difference as well. And what we find is when we dig deeper into something, we don't just want to see when something goes wrong, but we want to know what's causing it, what areas it's impacting, and how can we correct it before it impacts more customers or more parts of the application. So how is observability different from monitoring? Monitoring is about telling you the state of the system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored, then we have no idea what's happening there. Observability goes beyond monitoring by bringing together logs, metrics, traces, other data sources to give us a broader view and a deeper context. So, like I said, just wanted to kind of focus on our definitions there. And so we'll be focusing on observability. Now, that being said, monitoring is a portion of observability. In this slide, what we're showing here is our unified observability platform. And what we found is one aspect to achieve end-to-end reliability is having a unified platform. And what does that mean? Well, starting on the left-hand side of the screen, what we're seeing here is that it's required to get all bits of data telemetry to perform the tasks that teams who are in charge of reliability, DevOps, DevSecOps, from each and every layer that affects the application. Essentially, you have all these different data sources. Could be coming from your host, your servers, your application components, microservices, Kubernetes clusters, your CI/CD pipeline, et cetera, et cetera. And basically all that data needs to be brought into Sumo Logic. And when it is, and when you have that relevant data, you can now utilize Sumo for visibility and more specifically observability. So this allows you to monitor your alerts to give you the what's happening. But then it goes deeper. Using diagnostics or diagnosing, we're going to use trace spans to figure out where things are coming from. And then in the step 3 of troubleshooting, we're going to utilize root cause to show us essentially the cause of the analysis, giving us an indication of where things might have gone wrong. The system is going to use the advanced analytics to apply that. So monitoring is part of the observability platform of the definition of observability as well, but it's really just a step in there. And so once again, like I said, just that terminology level setting there. All right. And of course, any questions, please ask. A few more slides here. Actually, yeah, more than a few, but getting closer to the labs. So what I wanted to talk about in this slide is the monitor, diagnosing, and troubleshooting once again, but this time talk about it with both teams and use cases. So for example, who can benefit from observability? Well, SERs and DevOps. Those teams or those individuals that are responsible for monitoring the health of the application, they need observability. Why? Because they want to see how quickly they can monitor, diagnose, and troubleshoot application health issues. Who else can benefit from observability? Software engineers. By providing visibility into the software pipeline, collecting information about that pipeline and identifying issues within the software delivery process, teams can improve the quality as well as the delivery of their application. And then finally, who else can benefit from observability? Well, DevSecOps, security and teams that need to ensure the security posture of their applications. What's unique about the Sumo Logic observability solution is it addresses the needs of all these teams and personas in one integrated platform, excuse me. And of course, there's other teams, other users that can benefit from Sumo Logic, but these probably are most applicable to the job roles that you personally are tasked with. All right. All right, one more slide of the monitoring, diagnosing, troubleshooting. I think this is the last one of this kind of format, but just taking this content and just looking at it in a different way. And what we found is, as it says on the left-hand side of the screen, observability requires more data and richer analytics as you go from an alert to the problem resolution. So on the right-hand side of the screen, what we see is we're trying to do an iceberg slide here. And at the top, the tip of the iceberg, you can go ahead and start to monitor your systems. And that will give you the what. And to do so will take about 20% of your data. But as you want to get deeper into finding out the where, the why, the how, you're going to need more data. More data is going to require more sophisticated analytics. And that's what this is showing. So as you get a little bit deeper in wanting to know more information, you're going to need more data. It's sort of, makes sense, I hope. But that's what we're trying to show here. All right, so now that we've talked about the Sumo Logic observability solution, or Sumo Logic and observability, really, now we're going to go into the Sumo Logic AWS observability solution. So AWS, hopefully you're familiar with it and using it. If not, that's fine, I guess. But what we found is AWS encourages the use of separate AWS accounts to help manage costs and give teams independent administrative control. Additionally, different accounts often have different settings across regions depending on the needs of a specific app. Going deeper, as you'll see on the next slide, once you're in a certain account and a certain region, there's a multitude of services that customers can use to run their apps. And within each service, there's multiple entities or instances that correspond to it. These all have their own data monitoring. The problem with this complex hierarchy is it often leaves vast data silos where it can be difficult to acquire a clear picture of overall AWS service health regions and accounts. And so what we found, and I think you can probably agree with, or hopefully can, is you don't typically have a single AWS account. What we found is our customers have multiple accounts across multiple regions. So for example, their production data might be stored in US East and US West. Their QA data might be stored in US East 2. Their APAC information might be stored in APAC. And so you start to have different accounts in different regions. So how can you easily, or the challenge is, how do you start to look at your production data in APAC, as well as your dev data in the Middle East through a single pane of glass? And in AWS, it's hard to do. Well, you can't really do it. And so that's where we start to provide a solution to a problem. And continuing with that, and I alluded to the services, you have multiple services. So how do you start to look at your production data in APAC and your EC2 information? And what if you only want to look at your RDS information for your QA servers in Canada? Once again, how do you do that through a single pane of glass? Well, they'll show you shortly, but that's the challenge. The visibility across the AWS account regions and service hierarchies, excuse me. And as once again described, troubleshooting is complex. So what we can assist with is from complexity and chaos to clarity and root cause. What we're going to show you in about 30 seconds or so is that single pane of glass, a view into it and how it works and how easy it is to start to look at these different environments and different services that are going on or not going on, as the case may be. So that should be it for slides. Oh, one last slide. I like this one. This is a quote that I find funny, I don't know, or interesting. What it says is we replaced our monolith with microservices so that every outage could be more like a murder mystery. And what the kind of joke is, and once again, I don't know whether this really falls into the category of jokes, it's not that funny, but what we're going for, and why we find some humor in it, is the idea that you can now utilize our services or microservices to start to see that this thing happened or didn't happen at this time with correlation. So it's no longer just looking at something kind of blindly. You start to see, if you remember the old board game Clue, that it was Professor Plum in the observatory with the wrench, and start to put those pieces together. And the analytics is going to do it for you, as we'll see in just a moment. All right, so going to pause here. Any questions? I don't see any, which is fine. So I'll keep going. So what we want to talk about now is Root Cause Explorer. How can you start to utilize this tool to help you with the problems we just discussed? So let's see. I am not going to do the demo. I'm going to have us do this together shortly, but I want to give you kind of a preview of what you're about to see. This is a very scary version of it. There is a lot going on this screen, but I think it's a good, just a good illustration of what you'll see shortly. It won't be as busy as this. So what are we seeing? What's all this busyness that's going on? What we're seeing, or what we're utilizing, is Root Cause Explorer. And what we're seeing is over a time period, and the time period is the x-axis. And so in this case, it's the last 3 days. So we're looking at a 3-day time period. We see what we call EOIs, or events of interest. And what EOIs are is the system has found things that it thinks are interesting, anomalies for some reason. Well, we figure out the reason, but the system has determined them to be anomalies, excuse me, or outliers. And the y-axis is going to represent drift, essentially a deviation from the norm. So the system is telling us here, over the past 3 days, we have had a lot of unique events, or not unique, outlying events, or events that are interesting. Yeah, the system's really just calling them interesting at this point. Using the legend up here, we start to see some of those events are errors, some of them are bottlenecks, et cetera, et cetera. And so, and then on the right-hand side, with the events of interest, we start to see, for a specific event of interest, we get some graphical information, which is going to help us understand, or hopefully help us understand, the uniqueness of this event. That this event may not have happened yesterday, but it is happening today. And because of that, that's, you know, something to be aware of. I was going to say problematic. It doesn't have to always be problematic, but certainly something that's unique, and the system wants to point out to us. So like I said, just showing you this, but we'll get into it hands-on in just a moment. So let's go ahead through this use case that we're about to put you through using Root Cause Explorer. So for this use case, you are new employees of our sister company called Travelogic. And what Travelogic does is actually, let's go ahead and talk about it. Let me go on this slide first. What Travelogic does is it's a online travel agency. So you can go in and book hotels, book airfare. We get a percentage of the each sale. The customers get their, their airfare tickets and their vacations, and everyone's happy. And business is good. And business is good. And so we needed new employees, and so you're now part of the team. Well, what's your responsibility on this team? Well, you're specifically going to be a DevOps specialist for today. Hopefully you're familiar with that position. Actually, hopefully you're not. This will be a good feel for what that role does. So if you're not familiar with DevOps do, this will be a nice little walkthrough. And as a DevOps specialist, your role is to support the mission critical applications of the Travelogic app on AWS. We use AWS for our application. And you're going to be specifically focusing on ELB, application load balancers, that are actually referred to as ALBs. We'll talk about that in a second. Host EC2 and DynamoDB. So those are kind of your area of specialty that we're going to be focusing on today. You'll see more data than just these 3 areas, just because it's a demo environment. But for today, we really want to focus on those 3. And so what you see on the first day of your employment is that the end users are experiencing an outage in the application. So they're not able to use the Travelogic app to book their hotels. That stinks for them. It's a bad customer experience for us. And we want to resolve that, of course. Specifically, the end users are experiencing an application error of getting 500 errors. So when you go to a website and you get a 404 file not found, that's an error. In this case, they're getting 500 errors, which are going to be indicative of something, and we'll see what that something is shortly. Specifically, they're getting those 500 errors in the US East 1 area over the last 24 hours. So now as a DevOps specialist, it's our challenge and goal to troubleshoot this and figure out what's gone wrong and how to correct it. So how do we do that? Well, we're going to use the tools that are going to be supplied to us in a moment, but we're going to use Sumo Logic for that. Now we want to go ahead and log into Sumo Logic. So I'm going to go ahead and put these credentials into the chat. Oops, sorry, I'm blocking them. There we go. And let me just make that larger. So you should see them in the chat. And if you can't or whatever, but so the website is service.sumologic.com, which I hope you're familiar with. If you're not, that's where we go to log into Sumo. But we're going to use training credentials today because we want to use training data. The account you're going to use, our username, is going to be training plus analyst number, and you are going to pick a 3-digit number. So maybe you want to be training analyst 007, training analyst 321, 689, 427. I don't know, pick a 3-digit number. And then go ahead and use the password of Sumo Summer 21 exclamation point, and there's capitals in there. So capital SUMO, capital SUMMER, 21 exclamation point. So go ahead and log in now. Once you get logged in, if you can just let me know you got logged in. I don't really need to know the 3-digit number. We have a pretty small group, but just to confirm, somebody could get in. Perfect. Thank you, Manuel. And everyone else, go ahead and log in. Take your time. There's no rush. Well, I guess we'll rush. These credentials you can use after today, so they'll be good for the rest of the month. And they give you access to our training environment. So if you want to come back later and do these exercises again, or do more exercises or different, these credentials will work for you. Keep in mind, it is a training account. It is shared, so don't put anything proprietary in there, or and data gets deleted periodically, kind of standard, training environment rules. All right, so I see Manuel has logged in. Anyone else want to give me a confirmation they're in? And if not, that's fine too. All right, Steve, thank you. All right, there we go. All right, thank you all. Just want to make sure. Get a little nervous when it gets quiet. So once you're logged, all right, and if you're not logged in, let me go ahead and pause. I didn't mean to rush ahead. So if you're having problems with, let's see, the password, I'd recommend copying and pasting it in. If you're having a problem with the 3-digit number, I might choose a different one. So if you can't log in with 123, try another 3-digit number. It's possible somebody could have locked themselves out of it previously. Also, if you can't log in or don't want to log in, you're certainly welcome to just watch me drive. We're going to be doing the same stuff together, so you'll still get benefit from it. But I'd like you to, of course, log in. So, all right, so I'm going to go ahead and continue. If you have questions, like I said, go ahead and let me know. But let's go ahead and continue. So what I want to do here is I actually want to do these steps. I'll paste these in the chat, but let me go ahead and describe them and you'll follow along with me. All right. So we are in Sumo Logic. Oops. Sorry about that. Okay, what password did I say? Oop, now I'm typoing it. Now I'm all nervous. Okay. So this is the screen you should be brought to. Actually, I take that back. You should actually be brought to the home screen. So I have a bunch of tabs here. I'm going to close all the other tabs just to get rid of them. But you should be brought to a screen that looks pretty similar to this. I didn't do a poll. I should have done it earlier. How many people have logged in before? I didn't. So if this is your first time in Sumo, we will be kind of going quickly through it just to get to the portion that's relevant for today. The home page is a pretty normal home page with the idea of getting you up and running as quickly as possible. What we want to do first is we want to utilize the Explore feature to look at the observability, that single pane of glass that I alluded to earlier. So what I want us to do is go to either Explore by going home to Explore, or going plus new and Explore. Same difference as you'll find or may have found already. Many ways to do the same thing within Sumo Logic. So I'm going to go ahead and choose Explore. What I should get is a screen that looks pretty similar to this. And what we're starting to see are different views of our data, observability views. In this case, it defaults to Kubernetes. I don't really know why. I guess actually I do know why. It was the first one created, but we're not going to be using the Kubernetes service view for today. We're going to use the AWS Observability view. So what I'd like you to do is go to this down arrow under Explore By and select AWS Observability. When you do, you should get a screen that looks identical to this one. I'll go ahead and pause. If you need help, questions, let me know. But once again, those steps were, let me just show those steps. Those steps were going to New, going to Explore By, and selecting AWS Observability. And now we want to go a step deeper. Now we want to go to Prod and US East 1. Because in this, well, let me explain what we're seeing here. What are we seeing here? What we're seeing is our AWS data. This is the observability, the single pane of glass that I was describing. On the left-hand side of the screen, we see our different accounts, our dev account, our prod account, our staging account, our training account, those are the only, and a testing account. Within those, we have our regions. So here, for example, if I go to prod, I see US East 1 and US East 2. If I go to dev, I see US East 1, US East 2. But we could see, APAC, we could see EMEA, whatever would be appropriate here. In this case, we're just using kind of US-centric data. Now, here we're going to look at specifically production data because as a DevOps specialist, we want to investigate the production environment to find out what caused or what's associated with the 500 errors, and specifically US East 1. When we go into the US East 1 region, on the left-hand side of the screen, we should start to see our namespaces or our services. So now we see within US East 1, we see our AWS, well, it's all AWS, our application ELB, our DynamoDB services, our EC2s, our ECSs, et cetera, et cetera. Once again, now we're, that pane of glass is utilized and we're now digging in or drilling in, starting to get an understanding of what's going on. What we see at this very face value of prod US East 1 is information about AWS. So we see incoming activity locations. Where is our users, or I guess it's not to be a user, our computers, I guess nowadays really. Sorry about that. Where are they logging in from? From a security standpoint, this worldwide map might be helpful. If you are a US-centric company and you have no business in APAC and no users in APAC, and you've turned off access to APAC or what have you, and you see people logging in from there, that might be concerning. Certainly if you have customers or users or what have you in Australia, that would make sense. But now already this information is being provided to you. The AWS resource activity here, more graphical information, the different services over the last 24 hours, and what have they done in regards to creating, deleting, or updating what activities. For the right person, that's going to be helpful information. Now let's get back to our story here. We were interested in looking at prod US East 1, and that's what we're up to right now. What I want to show, and if you remember what we were talking about earlier, was Root Cause Explorer. Right now I'm looking at observability or observing observability, but I want to start to utilize that Root Cause Explorer that I showed earlier. What we have is a way to get into it from here. So what we're going to do is we're going to go up to the dashboards, and it should right now say AWS Region Overview. If it does, or when it does, go ahead and click on it and choose Selection 2, which is going to say AWS Region Events of Interest. By opening that up, what you're opening up is the events of interest. Now, this is Root Cause Explorer Lite or Junior. As we'll see shortly, Root Cause Explorer is a bit more elaborate or extensive than what we're seeing right now, but this is it's a junior or mini version is an okay way to describe it. Now, what we see in here, what do we see in here? What we see in here is over the last 24 hours, and remember, we're looking at US East 1, so we're looking at that area that we're interested in. We see events of interest. The system has determined that these points are odd. Now let's start to look at these points. Are they odd? Well, what are they? Right now, just on the legend, we see an error and a bottleneck. And for today, we're just going to use this portion right here, this sliver. We're not going to use the whole 24 hours. It's replicating data. So what do I see right here? Well, what I see is this red dot happened last. If I click on the red dot, what I see is it's associated with ELB app, production US East 1. The filter is automatically filtering it to that. Specifically, the metric of ELB 5XX code. So this is the 500 count that has spiked that I've been told or have heard that customers are experiencing. Now, I don't know what caused it yet, but I see the spike here. In the right-hand side of the screen, I see a graph here that's showing me the 500 count over the past hour for today, for yesterday, and for last Tuesday. And what it's showing me is that the blue is representing today. The light blue is representing the last 7 days. So 7 days ago, last Tuesday, there was not a spike in 500 errors. Yesterday, in green, there was not a spike in 500 errors. But today, there was a spike in 500 errors. Well, that's what I've been told, that there have been an increase in 500 errors, and now I have some proof of that. Now, the system is going to show us events that preceded this event and start to provide that causation and that correlation. So prior to this 500 error, the 500 errors just didn't magically happen. Something had to happen or not happen to cause these errors. So very simply, if we click on the event preceding that, we see a bottleneck. When we click on it or mouse over it, what we see is this bottleneck host, so that it's a bottleneck, is associated with the CPU load average. Essentially, what we're being told here is that a bottleneck has occurred and the CPU load average is higher than normal. Well, something essentially had to create that CPU load average. Something didn't spike the CPU on its own, something had to cause it. And so we need to figure out what caused the CPU spikes. So we're just going to go a little bit further back in time. And what we see here is a DynamoDB bottleneck. We see the DynamoDB bottleneck is showing us the read throttle events metric has spiked. And once again, that read throttle metric has spiked compared to yesterday as well as 7 days ago. And so this is letting us know that something was not, this is once again an anomaly or an outlier. Now what we're going to do here, let me just close this guy, is we're going to go ahead and click, and really, what I'm going to do now is just bring us into Root Cause Explorer. You're basically going to see the same information you just saw, but we're going to go into the actual Root Cause Explorer, not the junior version. And to do so, we're going to go to the right, click on the 3 dots, and choose Open. And actually, we're going to go straight to the dashboards. Let's just go straight to the dashboards. So what we're going to do is go ahead and look at the dashboards here. Let me just see, is this? Okay, so it's bring us basically to the same place. Let's see, I'm just, all right, so what I'd like you to do, I think I have a step messed up here in my lab, so I apologize for that. What I want us to do is go to New and go to Root Cause. And that's going to bring up the Root Cause Explorer. And so what we're going to do in here is we can go ahead and utilize the filters on the top of the screen to turn on or turn off that data that we want to look at. So for example, for today, we just want to look at the AWS data. So we can turn off the Kubernetes data. We can turn off the application service data. And then within the account ID, we can start to specify, oh, why don't I have prod data? This is what I was afraid of. Let me see here. Okay, so I'm going to go to the last 24 hours. And then I'm going to select prod. And then US East 1. But what I'm seeing now are those items that I just described earlier. The ELB error, the bottleneck related to CPU load average, and then the DynamoDB bottleneck. And what I want to do now is I want to start to drill in a little bit deeper. And so I want to start to see what caused these events. I see the events occurred, but I need to eventually use my logs to try and figure out, like I said, what caused them. So what I'm going to do here is I'm going to, let's see. So I'm going to go ahead and click on my DynamoDB bottleneck. So go ahead and click on this first event here, this DynamoDB bottleneck. And then what I'd like you to do is click on infrastructure. I'm crossing my fingers this works. What we're going to start to do is now view this data through a dashboard and start to just dig in a little bit further. So I'm going to go ahead and choose Open In here, Entity Dashboard. So what we did is we went to DynamoDB, we went to Infrastructure, we went to Open In, and now we're going to open in Entity Dashboard. And what this should do, or will do, is bring us to the relevant dashboard that's associated with this information, specifically this connector that's associated with DynamoDB. We're going to go ahead and change the dashboard we're looking at. By default, it brings us to a capacity planning dashboard, which is not relevant to this this story. And so what we want to select is the events one. I'm sorry, number 3 here. So once we're in here, we now start to see errors. And what we can start to see is possibly what has occurred and what caused these issues here. So we see an error has occurred. And if we scroll to the bottom, we see some log messages here. We're going to go ahead and select the log message associate. Oh, see, I don't see the mic one. So let's see. Why don't I see the one? Let me see. I'm missing my piece of data. I apologize. I'm not sure why it's not showing up. Yeah, I'm missing a piece of data in here. So let's take a step back and we can still just kind of wrap up this exercise and then go to the next one. But basically where we got up to is the fact that the read throttle event is spiking via DynamoDB. What we were hoping to show here is log messages associated with that spike. And what I was hoping to show is the fact that an error occurred and essentially an individual had deleted a table that was being utilized or not being utilized after it got deleted, that was going to impact the throughput and really kind of screw up the settings. Essentially, somebody inadvertently, human error occurred, they deleted something, it resulted in the spike of DynamoDB read throttle events. That spike resulted in or caused a CPU spike. And because of those 2 spikes, 500 errors were starting to occur. The system was overutilized. So that's what I was attempting to show. I apologize, it got a little bumpy there with that example. It worked this morning, but that's not a good excuse. So like I said, do apologize about that. Let's go ahead and get back into the deck, and the next example will work a lot better. And there's also a question in there. So let's see the question. The question is AWS Observability available to specific Sumo subscriptions? What AWS logs are required to set this up? Good question, very good question. I'm going to direct you to a help article. Actually to everybody, but let's go ahead and just take a look at this help article, which provides the answers to those questions and more. Basically, here is our observability. Oh, let me paste this in the chat. Here is a link to our observability solution content. And then based on what you're going to deploy, you're going to need to set up collection. So setting up collection is bringing the data into Sumo Logic. If it's AWS data, there's AWS steps. If it's Kubernetes data, there's Kubernetes steps. And they're all outlined very clearly, extremely clearly. And so to utilize and deploy AWS Observability, essentially what you're doing, and I know I'm on a tangent here, but it's a good question, is basically you're going to go into Sumo, go into AWS, utilize a CloudFormation template, provide an access ID and key pair to CloudFormation, and which basically says, on my behalf, send my data, AWS data to Sumo. Is more or less the gist. There's more legalese to it, but that's essentially it. And then once it's in Sumo, you have the out-of-the-box deployment, the solution, the configuration rather, excuse me, that's the word I was looking for. But then you can start to fine tune it. So what you can do, and we don't really go to it in this class, but you'll start to see up here with the some of the advanced features for the Root Cause Explorer, and these have some correlated admin settings, but you can start to say, only show me, drift if it's above whatever, 500%. Only show seasonality. This is a newer feature that lets you, based on time of the season, can start to adjust things. Only show me things that are positive, only show me things that are negative, and start to fine tune the system in that way. So you do have that ability. We just don't go into it. Let's see. Question about good question. Well, questions are good. So they're saying in their account ID is listed as just a random number, 1, 2, 3, 4, 5, where in ours we've had them labeled as prod, dev, etc. And how is that set up? That was set up during the ingestion period. So we can go ahead and say this data is production data. It's really importing the actual account IDs, but you do have the ability to overwrite those and start to use almost use metadata to start to create those names. So we don't cover that in this as well. We have an administrative class that we are developing. It'll be out in another 2 months that will go over those details. But the documentation should cover very thoroughly. And certainly if you have questions after that, reach out to our support, reach out to your account execs, whoever, but we'll get you the right person to help you with it. All right, so good questions, good tangent. Let's get back to the slides and let's get into tracing. Still have a little more content to go through. So with the slides, once again, apologize that the issue, but what we were doing here is we were identifying the error using the observability dashboards. We were locating these spikes, and we didn't see this one, but there was a spike in the dashboard. And then using Root Cause Explorer, we were starting to detect what caused the 500. And we were starting to establish context and utilize connections and start to see that ELB error is occurring. We used the filters to filter only the data that was relevant. And then the actual root cause was we at least got to this step of that read throttle events was spiked. And then we kind of saw, although was faking it a little bit, but that somebody had deleted something inappropriately, which basically screwed everything else up. All right, so let's go into tracing now. Tracing, we're going to use a different scenario for today. This scenario is better for many reasons. Today, we're going to be using Sumo Logic Coffee. So forget about Travel Logic. Now let's focus on Sumo Logic Coffee. As you know, Sumo Logic Coffee is a popular coffee brand around the world. We have locations, like it says, all over the world, and our goal is to deliver a hot, fast cup of coffee. Very similar to another company that uses a green logo, but for certain copyright and demo presentation reasons, today we're using Sumo Logic Coffee. Now, when you go to Sumo Logic Coffee, you place an order and you get a cup of coffee. It's pretty straightforward, but it's more detailed than that. There's actually various steps, microservices, if you will, that are taking place. The customer's going to place their order, possibly through an app. Little hint, but they may use an app, they may not. Actually, it's not relevant for today, but they're going to place their order. The order is going to go to the barista. The barista is going to start to interact with the coffee machine, and the machine's going to do the heavy work here. The machine's going to check, does it have an adequate ingredients? Does it have enough beans? If it does, it's going to grind the beans. It's going to check to make sure it has enough water. If it does, it's going to add the water. It's going to do its magic, and then the customer is going to have a cup of coffee ready for them. Now, unfortunately, we are a profit organization at Sumo Logic Coffee, and so we don't give free cups. We do, of course, to veterans and children, I guess. But we need to make money here. And so the customer is going to have to pay for that order. Credit card is going to be approved. For today, we're going to assume it's a non-cash transaction, only credit cards. And assuming the credit card is approved, then the customer can pick up their order. In that respect, each step is a microservice. And so once again, like I gave that my stupid quote earlier, it's we're starting to be able to start to see what's going on here. And so how can we start to see through computers and technology the brewing of a cup of coffee? Well, that's what we're about to explore right now. Here is an example of a successful order at Sumo Logic Coffee. I don't know, it looks like a lot of data and jargon, but what it is a visual representation of somebody placing a successful order. We see here the ID, so the transaction number. Remember, we're selling hundreds and thousands of cups of coffee around the world. We probably want to have a transaction ID so we can associate it to a store or whatever. So each order is unique in that respect. What we see here next to that transaction ID is a status code. A 200 is a successful status code. When you go to a website on the back end, a 200 status code is presented or captured. When you go to a website and you get a file not found or a page not found, you get a 404. That's a bad experience, a bad status code. And we're going to use those status codes a little bit for today. Not important that you know status codes, but we will just use them as examples. And what we see here with this 200, the successful order, is the various services that were involved in placing that order or fulfilling that order. We see the cash desk, that portion of the system that's in charge of money, running the credit card, checking prices, doing all that kind of math stuff. We see the coffee bar that's responsible for a portion of the ordering process, specifically capturing the type of beverage. We see the machine service, which is going to be responsible for the actual coffee machine, checking ingredient levels, checking status, making sure it's up and running or sleeping or what have you, and some other portions of the service. Now, this is what a good one looks like. As described, we want to start to look at some bad ones and start to diagnose what has gone wrong or what the status code is indicating to us. So how are we going to do that? Well, we're going to use tracing to do so. So now let's go ahead and walk through tracing. Hopefully you're still logged into the system. I'm going to assume you are. I guess assuming is bad, so let me go ahead and just paste those credentials into the chat one more time. But we're going to use that same account that we did earlier. And let me go ahead and just, like I said, just put those creds back in. Once you log in, or assuming you're still logged in, we're going to go to new and traces. So I'll show you right now. We're going to go up to plus new, and we're going to go to traces. And we're going to get the tracing environment here. Now we'll talk about this in more detail, but hopefully you're up to this step. So new traces, and you should see a bunch of traces in here. And once again, if you can't or don't want to participate, I'm walking through it, so you'll get the visual. All right, now let's go back to our slides just for one more slide here and describe the hands-on exercises. So what we want to do is we want to look at all the status codes, but what we want to do is start to look at the status codes and filter our data with this filter. And I'm going to paste it into the chat as well. What this filter is doing is very simply just limiting our service to just the coffee lover, which is what we call our Sumo Logic Coffee service internally or within Sumo. In this example, we are looking at other trace data that's not relevant to today's conversation. So we have payment data that's just not relevant. This is for another use case. And so I don't want to show that data just because it's not relevant. So what I want to do is filter specifically on the service of the coffee lover. Just show me coffee data. Once you've done that, you should see the screen should filter, and you should just see all the coffee lovers down here. Now, I want you to go ahead and click on status because we're going to utilize the statuses in a moment, and go ahead and sort them probably from low to high, but either way is fine. Now, what do we see on this trace screen for specifically the coffee lover? We see the trace ID, so that transaction number essentially, which might be helpful if somebody has a problem. We probably want to know which order was theirs. We see the root service, which is the coffee lover as just described. We see the started at, so when did the order start? When it was initiated. In this case, we're just looking at the last 15 minutes worth of data. We see the duration, which is going to be pretty important. How long did it take for the order to be fulfilled? How long did it take for the order to be completed? Was it fulfilled successfully or not? And duration is important. We want to get a fast cup of coffee, and so we probably want to know if it's taking milliseconds or seconds or minutes or longer. We also see a duration breakdown. We start to get a visual representation of those different services that are taking place and percentage-wise how much time they're taking. So here we see in this first one, the cash desk is taking a little bit longer than it did in the second one. May be helpful, may not be, but where the visuals are there. And then finally, we want to see the status column and the number of errors column. Now, as I described, a 200 is a successful order, so you can feel free to click on any of these 200s. and you'll see a successful order, no red. But now let's go ahead and look at some unsuccessful ones and start to try and figure out through tracing what caused the errors. So what I'm going to do is I'm going to scroll to the very bottom and I'm going to select the 503 first. So select one of the 503 status codes. And you'll also notice the number of errors. These 503s have errors where the 200s did not. The 200s were successful, so there's no errors. The 503s are not successful, hence errors. So what does a 503 mean? Well, let's click on a 503 and try and figure it out together. So I'm going to pick a 503, doesn't matter which one. What I'm looking for here are the errors. And what I'm focusing on is the red horizontal line, which is indicating to me that an error has occurred. I'm specifically going to focus on the lowest level of this chart because I want to get down to, if we're using that murder mystery analogy, down to the lowest level to see Professor Plum in the observatory. So I'm going to go down to the lowest level of red, and I'm going to ultimately click on this blue box, but I can also just hover on it. And when I do, I get some information. I see this blue box is associated with the water service, specifically the operation getting water. And so what this is telling me, or I guess leading me to believe, is that there seems to be some error with the water service getting water. That's good, but I need a little more information. I really need to know what has gone wrong here. And what I can do is I can look at logs that are associated with this event and visually see what went on. What I'm going to do here is I'm going to go ahead and click on the logs section here, and I'm going to choose the span ID. You can choose the trace ID. The span ID is just shorter, so it's just a little easier to visualize. But very simply, when I click on the span ID, what I should see in reverse chronological order is at the very bottom, I see info, received order for water in an amount of 4 milliliters. So the system order was placed for coffee. The system says, okay, the water amount that's needed is 4 milliliters. Error, not enough water. Requested 4 milliliters. So what this is telling me is that a 503 is indicative of the system not having enough water in it. If I go back to my traces and click on any of the 503s, I'm going to come to that same conclusion. Now, what do we do with this information? I don't know. We may want to create coffee machines that have bigger water reservoirs. We may want to put in our instruction manual for our employees that they need to check the water levels more frequently. We may want to, whatever we want to do with it, but this is starting to give us this information. Now let's go ahead, go back to traces, and now let's select a 502 and figure out what this means. So look for a 502, select one, look for the red lines, which are indicative of errors, look for the lowest level with errors, or the most granular. And when we mouse over it this time, we see it's this brown, I don't know what color that's supposed to be. And this time it's not related to the water service, it's related to the coffee service. Well, let's look at the logs and see what has gone wrong. What we see here is info received order for coffee grains. So the order was placed. The system needed 5 coffee grains to fulfill the order. There was lack of coffee grains. And through tracing, we're now able to view this. Last one here, I'm going to sort of rush through this. We're running close on time. But 402s, we can do the same thing. If we click on a 402, what we notice, or should notice, I'm going to tell you, is we don't see a red line related to the coffee services or the coffee machine anymore. We see this red line is associated with pay-in, which is associated with the cash desk. So right away, this is starting to tell us that there's probably an issue with some sort of payment issue. By clicking on pay-in and clicking on those logs, we can see at the very bottom, essentially the person ordered the item. The system is getting the product price. It's calculating the price because the person ordered multiple items, doing all the calculations, and then kind of yada, yada, yada. Essentially, the error was not enough money. The individual didn't have enough dollars on their credit card or whatever, and that was the cause of this issue. And so through tracings, we get to see that information, which is pretty cool and pretty unique as well. All right, let's go back to the slides. Let's see, we're pretty good. I see there's a question or two, so I want to leave time for questions. But the last thing I would just want to show here, or really remind you, is the idea of unified alerting. So within Sumo, we talked about the diagnosing and troubleshooting. We really focused on that portion today. The monitoring is an important feature of Sumo and an important portion of observability. And what we were just reminding you of is that ability to utilize Sumo logic for unified alerting. So that within Sumo, you can go ahead and, I'm not going to go much deeper than this, but just for a quick overview, you can go ahead and set up alerts in a much easier fashion. Basically, I can have an alert set up. When that alert is triggered based on some sort of value, I can have it produce an alert, an email, a Slack message, what have you. And a great way to get an understanding of and observe your system, with a bit ironically staying out of Sumo logic. So alerts are great, just kind of ran out of time with them. All right, let's get to questions. So the question for the traces is, are agents or plugins needed for or needed to install in the applications? In order to get these information for our Java application, we had to install a Java agent. So yes, I'm going to leave that really vague. It's a great question, Sam. It's a little more detailed than I feel comfortable going, but it is described in here. But let's go ahead and see if we can just find it real fast. But essentially, you're going to ingest your data through an agent, through a collector. Let's see. Getting started with transaction tracing. So here's the steps based on the collection, the type of data you want to bring in. You would follow the appropriate steps. So as you said, yeah, you may need to use the Java agent. If you're using .NET, there's another way to use OpenTelemetry. I'll go ahead and paste that into the chat because certainly a good question. That's something we'll cover in that administrative class that we're still developing. So I'll look forward to that class in October, maybe late September. All right, so I apologize that the middle lab there was a little bumpy. I guess that's, we're doing it live and those things happen, but like I said, do apologize for that. Hopefully you still, got a benefit or understanding of Root Cause Explorer. Any other questions for today's session? As a reminder, just for more info, always want to send you to sumologic.com/learn/training. This is the best place to find out about upcoming stuff, events we're doing, trainings and workshops, etc. Question was, the trace and span IDs get generated automatically? Oof. I believe so, yes. So in that respect, they're not when I was saying that if they were a transaction ID, that was not really correct terminology. In that case, I was utilizing them as such, but you would have a transaction ID and then a trace ID, potentially, depending on what you're bringing in, if it's a full transaction or not. Great. So thank you, everybody. I'll send out this presentation probably tomorrow morning. Maybe I'll get to it tonight, but basketball starts pretty soon. And I need to wait for the system to upload and all that. So I'll probably send it out tomorrow morning. But thank you again for attending. And please enjoy some more of these trainings. Oh, let's see. One more question by Hector. How do you carry trace and span IDs over transient data storage like SQSs? Hector's tech support is going to be the man for you, or the group for you. Yeah, you're just getting a little too deep for me. Valid questions completely, just a little deeper than I've learned so far already. Looks like Brenton might be able to help here with that question. Just seeing if, all right, so yeah. Let me paste in what Brenton just provided here, and feel free to drop if we're running a little bit long. But he did point to a good article on distributed tracing. It's a blog entry. I haven't had a chance to read it myself, but I will read it at halftime of today. I'll do that. But thank you for bringing that up. Good call, Brenton, on that link. All right, so thank you again for joining, and please attend the next one of these. Yeah, enjoy the rest of your evening. Thank you again. Have a good one, everybody.